Dear students, today we shall discuss next mechanism, that is toggle mechanism. So in slider crank mechanism, as the crank approaches one of its dead center position, the slider approaches 0. So as you can see in the figure, there are links CD, CE and CB and AB. So A is a fixed hinge and the link AB, it will rotate through a circle as shown in the dotted line. And here there is no link AC. They have indicated by dotted line, but there is a link BC. So when the link AB is rotating and when it is exactly vertical, it will coincide on the line AC. Now the angle made by link CD with respect to horizontal line is alpha, and similarly the angle made by the link CE with respect to horizontal line is alpha. So on both the sides the angle alpha will be same, and at point E there is a force F is acting. So the ratio of crank movement to the slider movement approaching infinity is proportional to the mechanical advantage. So this is principle used in toggle mechanism. So here toggle mechanism is used when large forces act through a short distances is required. So this mechanism is used when we need large forces on short distance. So if this is the application, then we have to go for toggle mechanism. The figure below shows toggle mechanism where links CD and CE are of same length. So in the figure, the links CD and CE are of equal length, and the angle subtended by CD and CE with respect to horizontal line is angle alpha. So alpha we have shown there. Link AB is fixed at hinge A and at point B. So BC is another link. Now we shall resolve the forces at point C vertically. So resolving forces, F sin alpha. So here we are going to resolve the vertical forces. So we have to consider vertical forces into consideration. So one is F sin alpha divided by cos alpha is equal to P by 2. So when the link AB is rotating and when it is vertical, it will coincide with the link AC. So I'll consider P by 2. So therefore F is equal to the ratio of sin alpha divided by cos alpha is tan alpha. So we shall send the tan alpha to RHS. F is equal to P by 2 tan alpha. So thus for given value of P, for any value of P, as the link CD and CE approaches collinear position, that is when the angle alpha is decreasing or it is tending to 0, the force F, it rises rapidly, and the force will be maximum for the condition alpha is equal to 0. When the angle alpha is equal to 0, the force F will be maximum. This is due to the link AB, which is rotating in circular direction with respect to the point A. So A is a fixed point and it is rotating. So during rotation, when it reaches the point to the vertical position, or when the link AB it coincides with the line P, then the force generated F will be maximum, because the angle alpha will be 0 and the force F will be maximum. In other conditions, the force will not be maximum and it will be less than the maximum force. So toggle mechanisms are used in toggle clamps, riveting machines, punch presses, stone crushers, etc. So toggle principle is also used in switches, circuit breaker, etc. So switch circuit breakers are electronic devices which we have already used. Stone crusher is the crushers which crushes the stone. So for construction of house purposes, there are we call it as jelly, small stones we call it as jelly, and these stones are crushed by stone crushers. So like that, punch presses are the presses which apply a large amount of forces for short distances, and riveting machines are the machines which are used to rivet the mechanical sheets. When we have to join the two sheets, there is a process called riveting. Riveting is applying nails and hitting with large forces. So that is called riveting, and the machines um, which are used for riveting, in that machine toggle mechanism is used. So next we shall see pantograph. So this is a simple mechanism. Here you can see that point O, there is a hinge at point O, and there is links OA, B, AD, AC, CD, BC, and the link BC is extended up to point P, and the point P, it is again connected by line OP, which is fixed at hinge O. So AB is parallel to DC and AD is parallel to BC. Link BA is extended to fix point or pin O. Q is a point on link AD. So from the figure, Q is a point on link AD on the link OP. So it is the intersection of OP and AD. If motion of Q is to be enlarged, then the link BC is extended to P such that O, Q and P are in a straight line. So here there is a line joined between O and P, and on link AD the point is marked as Q and they are all on a straight line. So then it can be shown that the points P and Q always move parallel and similar to each other over any path, straight or curved. So the motions will be proportional to their distance from the fixed point. So here we are going to prove that when the point P is moved from its initial position, here all the links are flexible, all the links are able to move. So when the link P or point P is moved, all the links or all the points change their positions, and it is proportional. The earlier mechanism or earlier shape is proportional to the new mechanism or new shape obtained, that we are going to prove now. So suppose let us consider the point Q, it is moving to point Q1. So here all the links are flexible links. So the point Q, it moves to Q1. So at the same time, point A moves to A1, B moves to B1, C moves to C1, D moves to D1, and P moves to P1. So the new points are shown by dotted lines, and these dotted lines are the new position obtained by the existing links. That is, the existing links A, B, C, D and P, they have moved to new position A1, B1, C1, D1 and P1. Now let us consider triangle OAQ and OBP. OAQ and OBP. So here OQP is on the straight line, and thus OQ and OP coincide. So if you look at the figure, OQ and OP, they coincide, they both are on straight line. So angle AOQ is equal to angle BOP. From the figure, angle AOQ is equal to angle BOP. Also OAQ, angle OAQ is equal to angle OBP. So therefore triangles OAQ and triangle OBP are similar. So thus we can conclude that triangle OAQ and triangle OBP are similar. So we can take the ratio of similar triangles. So the ratio of OA by OB is equal to OQ by OP. So these are the ratios we can consider when the triangles are similar. Next, from the displaced position. So now we are moving on to the new position of the links, that is A1, B1, C1, D1, P1. So in triangle OA1, Q1, OA1, Q1 and triangle OB1, P1. So again these triangles are similar. OA1, Q1 and OB1, P1 are similar. Therefore, we can take the ratio of OA1 by OB1 is equal to OQ1 by OP1. So the ratio of OA1 by OB1 is equal to OQ1 by OP1. So we shall call this as equation 2, and we shall call the equation 1 as OA by OB is equal to OQ by OP. We shall call this as equation 1. So from equation 1 and 2, or from the figure, we can easily conclude that the length OB1 is equal to OB. The length OB1 is equal to OB, and the length OA1 is equal to OA. So these because these are the same link. So wherever the links move, their lengths it remains the same. So we can conclude that OA by OB is equal to OQ1 by OP1. So from 1 and 2, OA by OB is equal to OQ1 by OP1. So also OQ by OP is equal to OQ1 by OP1. So this is equal to constant. The ratio it will be constant because wherever the links move, the ratios remains the same. So these paths are in the ratio PP1 by QQ1 is equal to OB by OA. From figure you can see that PP1 divided by QQ1. So P1 is the new displaced position and Q1 is the new displaced position. P and Q are the initial positions. So we can take the ratio of PP1 by QQ1 and that ratio will be equal to OB by OA. So this is what the pantograph means. So the pantograph mechanism, this can be used to enlarge or make small of the images or sketches. So if there are any images or sketches, we can enlarge that image or sketch, or we can decrease the size of the sketch also. So pantograph is mainly used in this process. So enlarging and diminishing of sketches, we can use pantographs. Thank you guys.